In this video, I'm going to go over finding the inverses of functions. Now, before I get on to explain exactly what those are, let's take a real-world example. As close to the real world as we can get, really. You may recognize this formula here. It takes Fahrenheit degrees and converts it into Celsius, right? You may have seen that in science class. But you may need to go from Celsius to Fahrenheit as well. Now, you could use the same formula. You just plug in your Celsius and you solve for F, right? Well, or you could find the other equation that takes the Celsius and mathematically gives you Fahrenheit, right? How do we do that? Well, we just solve for F, right? This is a formula, but picture it now like it's a function, like F of capital F. Maybe that's too complicated. Let's just say C of F equals 5/9 F minus 32, right? It's a function in terms of F Fahrenheit, right? Now, we're just going to swap. We want to make our input here our new output. So, what do? We just solve for F. That's all we're doing. We're solving for F in terms of C. Okay? So, what do we do first? Well, we got to get rid of this 5/9, right? So, let me rewrite it again. In order to get rid of the 5/9, we have to multiply. Let's use brackets, actually. We have to multiply both sides of the equation, because whatever you do to one side of the equation, you have to do the other, right? By the reciprocal of 5/9, right? So 9/5. That way, your 9 divided by 9 cancels out, and 5 divided by 5 cancels out. So we got to multiply this side by 9/5 as well. Yeah, you've probably done this before in science class. You didn't realize you were doing an inverse function here, or finding the inverse function. And we're left with F minus 32. What do we do next? Add 32 to both sides. And we're left with 9/5 C plus 32 equals F. And you can go ahead and put that equal sign on the other side. And there's your equation for finding Fahrenheit when you're starting from Celsius. Now, this is the inverse function of that. That's what it is. Now, let's talk about what that means. It just means that we've solved and kind of pulled this equation inside out so that the output for this equation is now the input of our new equation. All right, let's do an example of one that's a little bit more complicated. And first, let's talk about the notation. When we're talking about an inverse function, this is the function in question, right? This is the notation we use to represent the inverse function. It is a -1 exponent, right? And the way you say this is just inverse f of x, or f of x inverse, okay? Now, please understand, this is just a notation. Okay, usually when you get something to the -1 power, your instinct is to just go, oh, it's 1 over, it's the reciprocal of this, right? And then that makes the exponent positive, so we're good. This is not that, okay? F inverse of x does not equal 1 over f of x. And we're going to prove that right here. See, you take this f of x and you say 1 over what? 1/4 x minus 2 squared. I think you'll find that is not the inverse of x. That is just 1 over f of x. All right, so let's find the inverse of this. Could be a little complicated. Now, I don't know what your teacher would do, but for me, we're going to swap the input and the output, right? So I'm just going to rewrite this whole thing, but instead of putting f of x, I'm going to put x, because that's what we're trying to get, right? Our inverse function is still going to be in terms of x. And then equals, parentheses, 1/4. Instead of putting x here, I'll put y. You know, it's still a variable. It doesn't give me a whole complicated notation thing to worry about. It's just y. That's what we're solving for. We're trying to get y by itself, because that will be our inverse function. We will have swapped the output and the input, right? So how do we get y by itself? Well, we go try and move our way inward and try and get rid of everything around it, right? So first thing is this exponent. We're squaring the entire parentheses, right? So in order to get rid of that, we need to take the square root of both sides. Square root of a square is whatever's underneath it, so 1/4 y minus 2, okay? Square root of x. Normally you'd be plus or minus, but we're just going to assume everything's positive here. Now, what do we do? Well, let's add 2. That's a little easier, right? Then multiplying the whole thing by 4. Square root of x plus 2 equals 1/4 y. And you get the y by itself. Multiply both sides by 4, right? So you multiply a fraction by its reciprocal, it cancels out. And you're left with 4 times the quantity, square root of x plus 2. So 4 square root of x plus 8, right? Because we've got to distribute that 4 to both terms. Okay, now I could tell you this is the right answer, but maybe I'm not sure. How would we check to see if we're sure? Well, we know that it's not 1 over f of x. So keep that in mind and don't ever do that. It's just a notation. It's not an actual exponent. Now, this is f inverse of x. So how do we check our answer? Well, there's a rule. A kind of fun thing to know about a function and its inverse. If you were to substitute the function's inverse into the original function, such as f of f inverse of x, you will always get x, just the output by itself. So let's see if that happens when we take inverse of x, f inverse of x, and put it back in for our input here. All right. Another way to write that is f inverse of x. It's a good thing we know our notations, right? Or we'd be really confused looking at this. So what do we start with? Parentheses, right? 1/4. And instead of x, we're going to put this whole thing, 4 square root of x plus 8. And then continue. -2. And the whole thing squared. I think you'll find this math to be kind of easy. 1/4 distributed into the parentheses, right? That's what we do first. 1/4 times 4 is 1. Square root of 8. 1/4 times 8 is 8 divided by 4, which is 2, right? -2. And still everything is squared. +2 minus 2 is 0, so those cancel out. So we're left with square root of x squared, which is, I'll put equal signs in, x. So we just confirmed that 4 square root of x plus 8 is the inverse of 1/4 x minus 2 quantity squared. Two more examples, and I think we'll have enough practice, right? Now, you may have noticed that in none of my examples have I included quadratic equations. That's because I'm pretty sure you can't have an inverse of a quadratic equation because there's 2 x's in there, x squared plus x minus whatever constant, plus or minus whatever constant. So only one input value means only one output value, so we can have an inverse of it. So let's get started with h of x here. H inverse of x is what? Well, we'll change h of x to x, and we'll change that x to y, and solve for y. No problem, right? Divide both sides by 3. X over 3 plus, it's 42 divided by 3. Do some quick math over here. $14. Okay. Square root both sides, right? H inverse of x. You can check my math by putting that whole thing in for x up here, or vice versa. You could put this whole thing in for x down here, and you should get x. All right, let's do g of x. Cube root of the quantity x minus 4. Okay. Well, let's change g of x to x. Cube root of y minus 4. All right, how do we get rid of that cube root? Cube it. Cube both sides. X cubed equals y minus 4. Add 4 to both sides. Bam. This one would be pretty easy to check, so why don't we just check it? let's do let's substitute the original function in for inverse of g, just to show that either way you go, you're going to get x out of it. So take this cube root of x minus 4 cubed, because we're substituting in that for the x there, plus 4. Okay. You cube a cube root, you're left with exponent of 1. Negative 4 plus 4 is 0. It cancels out, so we're just left with x. So, successfully checked our answer there. Thank you for watching.